All right, so here's the last thing I want to talk about today, and that's the other type of angle pair that exists when two lines intersect, and that is vertical angles. So if you take the adjacent angles when two lines intersect, you have linear pair. When you take the angles that are not adjacent to each other, then you have vertical angles. So if we look at these examples here, or this same set of intersecting lines, the vertical angle pairs with angle 1 is the only angle that's not adjacent to it. So 2 and 4 are adjacent to it, so the only angle not adjacent is 3. And then for angle 2, the non-adjacent angle with angle 2 is angle 4. So there's only these two pair of vertical angles in when you look at intersecting lines. All right, there's a specific property that exists in vertical angles. Is there anybody who's familiar with that property? You guys have probably been exposed to it. Olivia, what? Yeah, they're equal to each other. Okay? So in this, the property is vertical angles are equal to each other. Okay, now this is a property that you've seen before. It's one that's going to be really common. We'll want to use this property in formal proofs. So in order for us to use this property in a formal proof, we have to go through the process of formally proving it itself. Okay, so what we're going to do right now, here in just a couple steps, is we're going to take this set of intersecting lines and we're going to prove that vertical angles are indeed equal from a formal proof standpoint. Okay, so we're going to prove that angle 1 and angle 3, pair of vertical angles here, are equal. Okay, so let's go through this proof. It's only going to take probably 4 steps. We're going to begin with our given information. Even though it really doesn't ever get used, we still need to start somewhere, and we need to make sure whatever the given information is, that's what we begin with. All right, so we want to show that these angles 1 and 3 are equal to each other. So the first approach to any proof is you want to make sure you introduce the end state elements. So our end state elements are angle 1 and angle 3. So let's introduce angle 1. What relationship do we know involves angle 1 based on what we just talked about? Measure of angle 1, measure of angle 2 is equal to what? 180, right? Okay, and we know that because what type of angles are those? They're a linear pair. So by definition of linear pair, we can make that statement. So we've introduced angle 1. Again, we can only use definitions, postulates, axioms, and previously proven theorems. We haven't proven any theorems yet, so we're limited to just postulates, axioms, and definitions. So we have a definition of linear pair. We were able to introduce angle 1 into our proof. How can we introduce angle 3? There's two different relationships that involve angle 3, right? We can either say angles 3 and 4 are equal, or we can say, add up to 180, or we can say angles 2 and 3 add up to 180. Which one should we choose? 2 and 3, right? Because we already have angle 2 in our proof. So you want to try to use pieces that are already involved in the proof. So angle 2 plus angle 3 will also equal 180. So we've introduced both of our end state elements. The next step in our proof is going to be to somehow manipulate them so that angle 1 is on the left side of the equation, angle 3 is on the right side of the same equation. So what do we see here? We have two things that are equal to the same thing. Therefore, what can we say about those two things? Angle 1 plus angle 2 is equal to angle 2 plus angle 3. Two things equal to the same thing are equal to each other by transitive property or substitution. Okay, so by transitive property, we now have angle 1 plus angle 2 equals angle 2 plus angle 3. What's the last thing we need to do to both sides of the equation to be left with our end state? subtract the same value from both sides, and that leaves us, angle 1, measure of angle 1 is equal to measure of angle 3, and the process we used was subtraction property. Okay, so what we've done here in just these 4 steps is we've proven our first theorem. Okay, so a theorem is a formally proven statement. Okay, and the formally proven relationship that we have here is this property of vertical angles. So what we can now state anytime we want to in any proof is that vertical angles are equal, and we can abbreviate it VA. Right, so this is the first theorem that we have. Okay, vertical angles are equal. And again, if it shows up in a proof, which you'll see in the next section, okay, we can simply call it VA. VA is the abbreviation for vertical angles are equal.